visual, physical, and acoustic elements, often incorporating technology to create immersive and multidimensional experiences. Computational thinking and digital tools enrich every aspect of Ted's work, which has been described as an impressive achievement both artistically and technically. And I think after today and tomorrow's concert, you will all agree. His music has been presented by institutions such as Mass MoCA, South by Southwest, the Walker Art Center, and performed by ensembles such as Jack Quartet, International Contemporary Ensemble, and Talia Ensemble. Ted is also a frequent improviser with electronics in spaces ranging from concert stages to dirty basements, and has appeared with instrumental collaborators on releases for Carrier, Mother Brain, Noise Pelican, and Avid Sound Records. Described as frankly unsafe by I Care If You Listen, which perfect full quote right there, performances on his custom, large-scale software instrument enable an improvisational voice rooted in free jazz, noise music, and music contract. So I'm delighted to welcome some danger into all of our lives, and I present to you Ted Moore.
Hello. Thank you for having me. It's lovely to be here and to meet you all. I've met many of you, but I've also not met many of you, so please come find me. I'm going to try to hang out in the lobby a lot, so come say hi and love to hear what you're up to, what you're making, and get to know you. Until this morning, I was going to do a totally different presentation. And then I met many of you and was talking to you about the things you're interested in and what you're doing and sort of seeing the sort of questions you're having. And I thought, I don't know, maybe I should do this other presentation that I just made today, but I think will be interesting and might be the sort of conversations I've been hearing happening. So we'll see how it goes. So the title of my talk is Composing as Data, Data Structures, and File Management. I hope it won't be as boring as it sounds. I think the actual title is something more like Finding Musicality in Data Structures, and yes, maybe also file management. Finding musicality in data is sort of the way I've been describing my work over the last couple years. And so I'm going to share with you a couple projects to give you a sense of my workflow about how I'm doing that, how I'm thinking about that, and also maybe like show you a little more behind the scenes of like actually the kind of files and file management that I'm using to do these things, because I think it might give a richer texture of like how I think about creativity with media and with computers and with technology. So the first piece I'm going to talk about is called Saccades. It's for saxophone, tape, and video. And I'm going to walk through the creative process of one of the parts of the piece. So this piece is based on a bunch of video that I recorded of my eyeball. I just knew that I wanted to use this in the piece. Set up my iPhone, just recorded some gestures, me looking around. I knew I wanted it to be a little bit frenetic, a little bit anxious looking. And then I took that video and I did some tracking to find the pupil position and the top eyelid and bottom eyelid for every single video frame, so I could have that data about where the eyeball was looking, whether it was open or closed. You can see the pupil dot on the bottom, and the yellow bar on the right is the eyelid positions. I first tried to do this with like video tracking software. There's like things that are made to do this, but I found it was really not good, at least at this video. So I ended up writing a little software that would show me each video frame one at a time, and I would click my mouse right in the middle of the pupil on, it ended up being like 5,000 and some video frames. Clicking, 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 because I found that the data would be much more clean, much more accurate, and when doing things like machine learning and data science, having good, clean data is really important. Having human-labeled data is really important, and so I felt like I was kind of putting in the hard work or doing it the right way. Make sure my data is clean, so I'll do this the right way. Then what I did was I took this data and I chose, here I have 10 different video frames, and for each one of those video frames, these happen at different points in the video. I have the X position, the Y position of the pupil, the position of the top eyelid and bottom eyelid. And I had all this data for these video frames, and then I chose some synthesis parameters for this synthesis algorithm called the Benjamin. You see there in the middle. And it has about 10 parameters down here. And I chose 10 sort of synthesizer presets that I liked the sound of and I wanted to use in my composition. I then, this will be very familiar if you were just in the Flucoma workshop. This should all be resonating very quickly. I then used a neural network to learn the relationship between these inputs and outputs, such that when the pupil positions, the eyeball values, were in a certain place, the neural network would have learned, to predict a certain set of synthesis parameters to generate a particular kind of sound. And so I had 10 eyeball positions paired with 10 synthesis parameters. The neural network learns that relationship I want between them and knows how to predict certain synthesis parameters and sound outputs from eyeball positions, given my aesthetic that I chose, that I wanted to use. So as a result of this, I can play back the eyeball video, and as the eyeball moves around, the pupil will be in some spot, the eyelids will be in some spot. I'll take those values, feed them to the neural network, which will then make a prediction of what synthesis parameters it thinks I want to correlate with that eyeball position. So that the eyeball controls the synthesis in real time. This is one of many sort of recordings I did of this, using different synthesizers, different eyeball positions as the chosen values, different synthesis parameters for different synthesizers. And I recorded a bunch of these, and then I watched through them all and found particular moments and gestures that I liked, and actually cut those out and ended up putting those into the piece. We'll see an excerpt in a little bit. And also layering them on top of each other. So I'm not so interested in just training an algorithm, generating an output, and calling it the work. I'm interested in thinking about these things, generating some data, playing with the ideas, generating lots of possibilities, and then from that selecting the results that I think are most artistically compelling to actually use in the work. We'll see that in a little bit, but first I'll talk about another part of it that we'll see. So, also in this piece, Saccades, I have some audio-reactive video design, where I'm also using a lot of stochastic processes, using random values to generate different parts of the video synthesis. I wrote some video synthesis modules in Open Frameworks. It's a C++ library for doing video and image creative coding. And here we have like one called Lines that draws lines. It draws it in very interesting ways, hopefully. But you can just see it's drawing some lines on the screen, making some nice rectangles at certain places. I also have some audio analyses happening in SuperCollider, being sent over to Open Frameworks over OSC, catching that data in C++, and then using these audio analyses to control the way that those lines and other things are generated. And so this software is paired with a SuperCollider script that I run them both at the same time, and it does real-time audio-reactive video generation. Also, I started doing this thing where I take my tape part that we'll hear and making a bunch of markers in Reaper, just like you would in any DAW, like marking positions in time. And Reaper has this feature where you can get Reaper to do this thing where you can actually export these markers as a text file. And it gives you each one of these markers as a position in audio samples, as in like 44,100 per second. That is the audio sample position of my marker, and then the content of the marker. So I can type in a little piece of information like OS1 or OS that number or etc. Some piece of information that I want to happen at that moment in time. And then I can take those markers, load them or send them over to Open Frameworks and use those as trigger points or as particular changes or control information inside of my video synthesis software to have certain things happen. So we'll see some of that happen as well. Also with this software, I made these big config files. This is a JSON file that has a bunch of parameters about how I want the video synthesis to happen. Like, what is the width and height of the video? Am I going to render this in non-real time, like one video frame at a time, or am I going to watch it in real time and like see how it's reacting? Where should I save it? What blend modes should be used? Should there be video feedback in it? Also, for all of the modules, I have parameters that control probabilities, like for the lines. How probable should it be that the alpha is a certain color? Or here we have a video I'm loading in called arcs0, and I'm saying, what is the probability that the video should be tiled? Or what is the maximum speed that the video should play back at? Or what is the minimum speed that the video should play back at within some like randomization parameters? So then I can take these config files, or this config file here, and use it to render 10 of these videos at once and save them all to disk. And because it's stochastic, there's going to be some randomization. All of these rendered videos are going to be different. They're all audio reactive. They're all doing certain things at those trigger points that I put in with the Reaper markers, with those little strings. But there's going to be 10 video files on my computer now that all are potential candidates or are part of the piece, or might end up in the piece. So then what I do is I find ways of looking through all of those videos, here's 6 of them, and watching when is it interesting. Like this is all kind of randomly generated, right? Some of these things are happening randomly, the colors can be random. Ooh, I like it when that one, ooh, that was a good one, or maybe I want to layer the two, or maybe I want to not use that thing, or maybe I want to go tweak some parameters and change, you know, the gray happens too often, let me turn the probability down on that. And I go through all of these video files and watch them like as big grids like this, and then make decisions about how I want to tweak those parameters further, go render more, etc. And then when I'm making the final version of the video, I line all these up in Premiere Pro as a big stack of videos, and I actually edit between them. It's like for these 2 seconds, I want to use video 4. For these 3 seconds, I want to use video 5. For this 1 second, I want to use video 1. I'm actually re-editing that stuff moment by moment to actually grab the part of that video render that I think is most interesting at that moment in time. This video is actually from, you'll see this piece tomorrow night, Splice will play what this video is from. So here's an excerpt of Saccades. We'll just watch the first 2 movements, which is about 8 minutes, and we'll see some of that stochastic video design, and then we'll see the eyeball controlling the synthesizer, and then we'll talk about something else. the second movement. So I've had people ask me if I edited that video by hand, and I tell them no, I do it programmatically, but I've never really explained like why I go through this whole thing of doing all of this rendering and all of these data files and the config files. So the reason why I try to do this is because I really like it when I see media or art or something that really gives me a new media experience. I think we're like, when we move through the world, whether we're seeing art or other things, we're all sort of aware of the ambient media ideas and tropes and patterns that we see. And we can see a poster on the wall and it's like, oh, that was probably made in Premiere Pro, or sorry, made in Adobe Illustrator or something. We see a video, it's like, oh, they're video editors, Premiere Pro, this and that, or whatever. But sometimes I see something and I think like, oh wow, I don't know how they did that. Like, what is that? Like, it gives me a different sort of feeling, a different sort of experience with the media itself. And so doing all these things idiosyncratically, like making my own video modules, my own synthesis algorithms, training my own neural networks, rendering all these files, going through it and hand-picking specific moments. I'm really trying to create things where it makes, at least me, hopefully others, sort of turn the brain into a slightly different state of perception, where my attention is sort of grabbed differently. It's not like, oh, I've seen this before, it's interesting, the content is nice, I like the music, but actually my brain sort of short circuits, like, oh, what am I seeing? Like, what is this thing that's going on? Like, is that eyeball controlling the synthesizer? Is the synthesizer controlling the eyeball? Like, why are there so many flashing colors? Like, is this, how is this happening? Like, this is sort of the type of experience I'm trying to create. Okay, so I'm going to talk about another way of managing data to try to create something like that. And that is that I was asked to bring this piece, Saccades, to the Alisphere, which is a big, like, 3-story, 360-degree video sphere with 54, I think, channel surround sound at UC Santa Barbara. It looks like this. This is a person standing on the catwalk. In order to actually be in the space, you have to go on this catwalk that's on the 2nd floor. So you're like looking down a story to this video and up a story to this video. And so I wanted to try to make Saccades fit in that space and not just like project my, HD video on the wall and just have people standing on a catwalk looking at the wall. So I wanted to see how could I change this media to make it fit in that space and really feel like it's for the Alisphere. So one of the things I did was I took all of the still frames from the video and used a image analysis tool in the Google package called MediaPipe that does a sort of image embedding. So it analyzes each one of these images, and that many thousands of images, more than this, but it analyzes each one of these images and tries to represent it as I think it's 512 numbers. So how can I find a 512 number vector to represent this image? Then I can take that value, those numbers, and do some more machine learning with it, do some dimensionality reduction tools, which we'll talk about in the Glaucoma workshop on Thursday, and embed these eyeballs into a lower dimensional space, like this 2-dimensional space here. You can see, the closed eyeballs are on the right, looking to the right is up in the top left, looking to the left is at the bottom, and these eyeballs are organized according to similarity. Here's a 2-dimensional representation of that. Sort of interesting to look at. And I was also able to do the process slightly differently and get a 3-dimensional representation of where all those eyeballs might be organized in a 3-dimensional space according to similarity. Here we're just seeing blue dots. It's not really useful, but that is actually the data of the eyeballs. So then I positioned all of these images of eyeballs in the 3D space of being in the Alisphere. So you're standing in this 3D sphere, you're seeing these eyeballs appear all around you, you're hearing these sounds that are triggering the eyeballs to appear, and you're sort of noticing, as this process unfolds, you sort of notice that, oh, all the closed eyeballs are over there. All the eyeballs looking to the right are over there. And it's sort of this moment of like, oh, there's actually something a little more related going on here. There's something like correlated going on here instead of just positioning the eyeballs in random positions. So here is an excerpt of that. Of course, we're not in the Alisphere, but maybe you'll be able to see it. So again, So again, an experience of like seeing a process happen and then having a moment of like realizing there's a little bit more unique something going on there. Another thing I wanted to do was surround the audience with eyeballs. And in order to do that, I had to render a video file that looked like this. This is called an equirectangular projection, which is actually the same sort of projection that we see on a map like this, where the Antarctica is like stretched across the bottom. Here's a still from one of the videos. But for this, I did a similar process as the video design for the first movement, which is that I made some software that would position these in this equirectangular projection, and then made a bunch of config files that I could specify different stochastic parameters to how I wanted to position the eyeballs around in space. So here's, where to get the images from, where to get the 3D positions from, what strategy I'm using for positioning the eyeballs, how long the images should remain or should be visible for, and I can use this config file to actually render out this video. What's nice about this is I can actually make a bunch of config files, all these JSON files, that all have different random parameters in them, and then again, just tell my computer to render all of them at once, save them all to disk, come back and watch all of them and decide which ones I like the most. Here's me just rendering all of these JSON files to video at once. So then I could get things like this, with the eyeballs like near to each other, being near to each other in the video, but you kind of get this like sweeping pattern going up from the floor to the ceiling. Or all the eyeballs at a random position in the video. Or the eyeballs in a random position at the video, but randomly positioned all around the space. And then I used them in the piece, sort of took these different renderings. Some of them were good. I mean, I showed you the three that I ended up using that we'll see in the excerpt. Some of them were interesting, some of them were not interesting. I ended up not using them. But then I used these and composed with them as though they were like some fixed media file and organized them to be in the third and fourth movements here. Okay, another thing I did in this space to try to adapt it for the Alisphere was I had to figure out how to take the original stereo tape part and spatialize it in 54 channels. And I was told I would have 1 hour in the space before the performance, so I knew that I had to just go in and swing for the fences or something, just cross my fingers. But what I wanted to try to do is figure out a way programmatically to have, again, there be like these sort of correlations between what's happening and the actual media itself. So we sort of notice these patterns or these similarities as we're listening to the piece. I wanted the first movement was the place where I really did the most with this because there's a lot happening and a lot of sound, and I had a lot of data for that. So this is the speaker map of the Allosphere. There's, I think, 30 speakers around the center, or the middle ring. Then there's a top ring of 12 and a bottom ring of 12. I decided that I was going to use some Flucoma tools to do some audio analysis on different moments in the piece, and then try to use that to spatialize the sound according to some audio patterns that I might find in that analysis. Because I knew that I had all those Reaper markers in movement 1 already positioned where those sounds change, I used those Reaper markers, loaded them into Super Collider, and then sliced all of my audio stems from my DAW session into individual sound slices, and loaded all of those stems back into Reaper so I could find those individual slices based on those markers and actually do some audio analysis with them. What I ended up doing was taking some, here's the stems in Reaper, sliced according to those markers. You can sort of see them spread out here. For each one of those audio clips, I did some audio analysis and found the spectral centroid, the MFCC values, a few other audio analyses, and then did this with them. I took all of those sound slices and organized them so that about 1/3 of the sound slices with the highest spectral centroid value, so the brightest sounds, or maybe the noisiest sounds, they went to the top ring. All of the sound slices that had the lowest spectral centroid values, or maybe the darker sounds, went to the bottom ring, and then everything else went to the middle ring. Then what I did, for each one of those rings, I took all of those sound slices, and based on their timbral analysis, using MFCCs, I organized them in a circle according to timbre, so that the timbres that were similar to each other would be near to each other on the circle. And then position them around the circle according to that analysis, so that sounds that were maybe a certain pitch would often end up in the same speaker, or sounds that were similar in brightness or noisiness would end up in similar places on the top, or the low thuds in the second movement would end up on the bottom. And then that ended up looking like this. I have it ended up being 60 channels of audio. I think there's only 54 speakers, but here's all the channels of audio positioned according to that similarity with the markers in there to make sure that they're lined up properly. And you can start to see some visual patterns just here that I was kind of pleased. I thought, oh, okay, that's interesting. Maybe there is something to this. Maybe it will work. And then I went in the space and played this back. And what I found, again, I couldn't listen to it beforehand, but what I found was when there were rhythmic patterns like, cha-choo-cha, cha-choo-cha, that it would actually move in the space similarly every time that pattern repeated. And if that pattern came back later in the piece or later in the movement, it would have a similar pattern to it or a similar shape. So it's this way of thinking about how can I get some correlation in the performance that we can notice, that we can hear based on these analyses, because I'm not going to be able to actually hear it in the space beforehand. And we're not going to listen to it because we only have 2 speakers, and that's fine. Okay. So there's, I think, just one more thing I will share. One more example. And it's actually kind of an old piece, but it comes to an interesting sort of reflection to make that I'll make at the end. So I wrote this piece in 2021 for the Switch Ensemble. This was a remote collaboration. So what I did was sent them some music and had them record the audio and video of them playing their individual parts to a click track and sent me back all that media. So at this point I had many minutes of recorded audio of this music that I had composed. I then just very crudely sliced this audio up every 100 milliseconds. I just called a new sound slice. So I ended up with many thousands of sound slices that were all 100 milliseconds long. I then used Flucoma to do some audio analysis on each one of these sound slices, getting spectral analyses, those MFCC values, pitch, loudness, all of this useful information. And I ended up with about 700 some values per sound slice. So I had thousands of sound slices, 700 dimensions per sound slice, much too much data to really be creative with. So I used one of these dimensionality reduction algorithms to take all of these sounds and organize them down into not 700 dimensional space, but a lower dimensional space. Here we're seeing the sound slices plot in 2 dimensions because we're looking at a screen. But I actually plotted them in 11 dimensions, which just means for each one of these sound slices, there were 11 values that described it in some way that I could use. The way these algorithms work is that those 11 values, they lose any sort of sense of human readability or like musical information. We can't know that, you know, the first value correlates to pitch or loudness, sort of lose that. But what it does give us is that the slices, when they're organized in this lower dimensional space, the slices that are near to each other will be similar to each other, and the slices that are far apart from each other will be more different from each other. This, again, this idea of similarity. I then used various algorithms to create a path through this 11-dimensional space that would visit each one of these sound slices exactly 1 time, but try to make that path as short as possible. And this is the traveling salesperson problem, a classic computational problem from computer science. And I used a couple different algorithms to create a couple different paths, because there are different strategies to think about how to do that efficiently or well, or you know, depending on what the data looks like, you might want to try different strategies. So then I took this path, or these many paths, and used them as a time series to reorganize these sound slices along that path through time. So now I had all of the original sound slices reorganized in this reconstructed path, hopefully according to some measure of similarity, because if they're near to each other on this path, they were probably near to each other in that 11-dimensional space. If they were near to each other in that 11-dimensional space, it's because they had similar audio analyses. So we're going to hear this reconstructed sound file in just a moment. First I'll orient you to this plot here. So each one of those dots is a sound slice. The colors are the result of a clustering algorithm that was done in 11-dimensional space. So the colors, the dots that are the same color, were near to each other when the dots were in 11 dimensions. Here we're looking at it in 2 dimensions because it's on a screen. And when I hit play, we're going to see a black line start to zigzag around, connecting all these dots. That's actually the path we're seeing unfold, and we'll hear that sound slice played back in real time. Also, on the left, we'll see a video excerpt of the performer actually playing that sound slice, so we'll get a sort of audio-visual representation of this path of similarity. After this video, we're going to watch, so this is a one-dimensional path created by an algorithm called UMAP. After this video, we're going to watch another video that's the same thing, but a different path created by a different algorithm. And sort of the curiosity is to compare the two, perhaps. So. So I was pleasantly surprised that the algorithm was able to find those similarities between the timbre, even pitch, and then organize them accordingly. That one that we just watched, that first like 40 seconds, the cello does this thing where it like starts low and then like goes up on the bridge and it starts playing high, like all these interesting shapes and gestures that emerge from that. Here's a different algorithm, the traveling sales, it's a sort of a generic traveling salesperson solver. And here's the result that it gave. So much more disjunct, one might say less successful in finding similarities and organizing them. However, as I was watching these, this second one, there are moments where like the piano kind of goes like, or the flute will go like, and it's like, oh, that was actually a really nice little musical gesture. Like that was a great little phrase. And it made me realize that like, I'm doing all this computation, I'm trying to use machine learning to find all these patterns, and there's like ideas about what is a well-trained neural network. What is a successful dimensionality reduction plot? What audio analyses tell us about similarity between sounds and how similarity might be useful? But then I sort of thought, well, actually, like, music isn't just things being similar or finding things that are similar and putting them next to each other. Or music isn't about, like, just having some algorithm, you know, for those of you who are just in the Flucom workshop, having the error, like, go down as close to 0 as possible and then, like, you know, making sound. Music is, like, about all sorts of things. It's about surprise and about things being disjointed and about having sounds that are similar be together, but then having sounds that are different be together and having form the way we organize all of that. And so it really made me realize, like, I really need to be careful and not just pursue using algorithms because they're cool or because they're interesting or because they make results that are surprising, you know, like the first one of these we saw. But really make sure that I'm like trying to filter all this stuff through what I think is actually musically interesting, What is the music I'm trying to make? How might these algorithms give me results that are interesting and surprising and cause these correlations that I like to have happen for listeners in the experience I'm making for them, but not have that be the thing that they're experiencing. I don't want the correlation to just be, oh, isn't that interesting how those sounds are similar and now they're near to each other. There should be some sort of musical value that is put on top of that. And so when I actually created this part of this piece in this project, I went through both of these and selected out phrases, gestures, little melodic motives, little lines, little parts that I liked, and cut them out and edited them together to create the final version of this section of the piece, to make sure that there's still a musical flow to it. Again, not just taking the output of the algorithm and presenting it as my artistic expression. Okay, I'm gonna stop there. I'm gonna say one more thing. So, if I may sum up a bit, or try to. So, I'm really interested in my idiosyncratic processes creating idiosyncratic artistic expressions. That's why I hand code my own things, because I think they make for distinct musical ideas. I'm really interested in using personal data, not using other people's data, to not be exploitative of other artists, but also because I think that those small data sets that are meaningful to me, when I curate those and collect those, they create meaning throughout the whole process all the way through to the final result. So that meaning is really important for me to preserve through the entire process. Generating outputs is easy. I can render 10 video designs all at once, all of which I could put into video, and it could be a video design of my piece. Finding the musicality in those, really what are the moments that feel special? What are the moments that feel expressive? How do I find those? How do I solicit those from the algorithms and then organize them to actually create the music? And I think a summary is that I try to use computers for what they're good at, like generating 10 videos at once, like predicting a bunch of synthesis parameters from audio analyses or from eyeball positions. Let the computers do all of that, and it's important for me to do what I'm good at, and I want to trust my own artistic vision, I want to trust my own ear, my eye, I want to know that I like that color because I like that color, and that's going in the piece for that reason. That's the thing that I'm good at, knowing what I like, and knowing what I think is important to share with an audience. Thank you. Any questions? We have 7 minutes. Yeah. What's your name?
Really intrigued by what you talked about at the end about finding musicality and focusing on what are the more sophisticated elements you're looking for other than correlations, and what are things that you like that you want to direct attention to. And I guess going off of that, what helps you keep that investigation fresh? What helps you keep your method of finding this musicality inspired?
Yeah. Well, so I mean, I really just go from my gut, like you know it when you see it, sort of vibes. Like, you know, I see a particular shape or hear a particular contour, and I just, ooh, yeah, that's good. I like it. That goes in. As far as keeping it fresh, I don't know. I mean, you know, I just try to see a lot of art and see like what's going on out there in the community and in the scene, and so that I sort of know when I see something in the processes I'm doing, so that I know when I see something that feels distinctly me, that feels like I have something to say, and it doesn't feel like I'm, I don't know, following trends or imitating others or sort of jumping on a bandwagon or whatever it is. Like I feel like, ooh, that feels like feels distinct. Feels like it has to do with my ideas and my processes and my results. So maybe that's an answer. In the back? Wait, was there? Yeah.
I noticed some of your deals with transcription, not just of melody, but of sound, and I'm wondering if you could talk a little about your relationship with transcription and like your own personal do's and don'ts, like when you like to and when you sort of steer away from it.
So yeah, so we saw in the first movement, the saxophone line is sort of a transcription of the tape part. I do all of that by ear. I don't use like analysis tools to do that because, again, it's this idea of like, I'm trained as a composer, like sitting down and writing a line for an instrumentalist is something I feel skilled to do. So I want to use that skill to do it, right? And that's going to be, I'm more skilled at that than a computer is going to be. So I should just use my ear to do that. Yeah, I mean, the thing the challenge with this task is that it's really makes for really bad orchestration because if there's a synth sound going psh, and then I'm asking the saxophone to go psh, it's like, well, now I just can't hear them because they're masking each other. So, but it's interesting. I mean, it's an interesting sound and shape to have that happen. So that's one thing that I try to be careful of, that I'm not just masking the acoustic performer by the electronics or vice versa. And so, but sometimes it happens and it's part of the aesthetic I'm going for, but making sure to sort of go in and out of that. And that's sort of a formal consideration when I choose to make those changes. So, yeah.
What are the dimensions you use when you have to find like similarities between the sounds? Like are you like pitch like frequency this or what are the other representative dimensions that we're using?
So the original audio analyses for that project were all of the audio analyses that are in the Flucoma toolkit. Because it was my first etude with Flucoma. I was like just trying to stretch it and see what it could do. And so I just threw it all at the wall and it worked pretty well. It was like, oh, okay. Now I would probably make more careful decisions. And it always comes down to the sound. Like, what do I care about in the sound? Do I want this to be organized similarly according to timbre? Do I want it to be organized similarly according to pitch? Both? Loudness? And so that's the choice. That's the decision. The audio analysis will reflect should reflect what you care about and what you're trying to achieve. Dan? Yeah, I think I was just thinking lower, lower, higher, higher. But I was thinking like, I need to try to spread this stuff out in a way that just is kind of like blunt. I can't get too clever with it, because if I get too clever with it, it's going to be harder to perceive if there are correlations, if it's too, so I just try to be blunt with it, to even see like, does that happen? One problem I found was that all the noisy samples were at the top because the spectral centroid was much higher, and so there's a lot of noisy parts of that tape part, and so there was kind of like, being in that dome, there's kind of a bright, too noisy thing there. So when we got in there during that hour, I was able to adjust a couple volumes and like tame that a bit. That was yes.
It's great to see this work again, by the way. Really beautiful to see it elsewhere. I wanted to ask you about workflow because, well, you're also like trained composer and started with composition, and there's so many technical parts added into it. And I was wondering, because for me personally, well, I'm trying to learn all those new devices,
Yeah, I mean, so that question is in some ways like the question, and that for me is central to all of these things that I do, because it is a lot. They gotta render this file, and then I send it to this program, and then it does it into that file, and then I render this, and then I render all that. So when I'm building these processes, the thing I try to do is, the one way of thinking about it is, how much creative exploration, possibility consideration can I do by changing as few characters in a file as possible? That's like the goal. Because if I can build a system where I can change a couple probabilities and then get a totally new version that is very different and maybe better, that I like, by just changing a few characters, that's really powerful, because then I can like explore lots of ideas very quickly on these sort of kind of large scales of these stochastic video processes. So that's one way that I think about it a lot. How can I organize my code or organize my project? And how can I automate systems so if I change something in step B, I can automate the process from step B to step F very quickly. So I can go back and change that thing in step B, render that out, get back to step F where I was in the process. I don't have a good example of that, but this is like a good example. The config files are really where like so much artistic exploration and expression ends up happening. Kind of a weird place for it to happen, but it really is where I feel like it happens. So, we're at time.